Hi everyone, this is Miss Smidra. If you were absent yesterday or just need a little review on which change happened first when we're looking at a chart, this video is for you. Please use your page protector and write out and draw out the examples as I do them in this video. So for example, say that you had a chart with grass, mouse, snake, and so if I'm making a food chain with this, so I know that the grass gets eaten by the mouse, and then I know that the mouse gets eaten by the snake, so I'm just drawing my food chain. You can do this on your whiteboard if you'd like. Now, if I'm looking at the numbers from 1990 to 1991, what I would first do is try to figure out what happened between those numbers for each population. So if I'm looking at the grass, if 1990 it had 57 and then it went to 72, that would be an increase. Now, if the mouse population went from 32 to 44, we know that that would also be an increase. Now, if the snake population went from 7 to 10, that would also be an increase. So if I'm drawing out my arrows on my food chain up above, I'm trying to figure out what happened first. So if I started with the snake increased, would that cause the mouse population to increase? No, because if there's more predators for the mouse, then it's going to actually decrease. So that couldn't have happened first. The mouse increased, would that cause the snake to increase? Yes, because there's more prey for the snake to eat, but it would not cause the grass to increase because there would be more predators. Now, if the grass increased first, would that cause its predator to increase? Yes, because it would have more food, which would then cause the snake to increase, which is leading us to the grass was the first one to change from this food chain. If you notice, the producers, the grass producers, cause everything else in the food chain to change. Now let's look at another food chain. So if I have a plant gets eaten by the insect, which gets eaten by the turkey, which gets eaten by the fox. And I'm just going to look at what happened in 2001 to 2002, what happened with those populations. So if I'm looking at 3,400 to 4,600 of plants, we know that that population increased. Now, if I'm looking at my insects, 2,670 to 1,802, well, that decreased. 340 to 440, well, that population increased. 71 to 83, that population increased. And I'm just going to draw my arrows right up above my food chain so that I know what I'm looking for. So if I'm trying to figure out what population changed first, with this one, let's look at plants first. So if the plants increased, would that cause a decrease in insects? No way, because the plants are the prey of the insects. So if there's more food, then the insects would have actually gone up. So that can't be true. The insects decreased. Would that cause the plants to increase? Yes, because the plants would be the prey for the insects, so they wouldn't have as many predators. The plants wouldn't. But that would not cause the increase in turkey because they wouldn't have as much food, so the insects couldn't happen first. Now, if I'm looking at my turkey increased. Would that cause my insects to decrease? Yes, because they would have more predators, which would then cause my plants to increase. And then if my turkey was the first one to increase, then my fox would increase as well because they would have more food. So I'm going to put a dot next to it to see if that worked. Now if I'm looking at my fox, if my fox increased, would that cause my turkeys to increase? No, because they would have more predators. So that means that my turkey was the one that went first. If you recall from the video that I had you watch a couple days ago where that guy gave you a little cheat where whatever happened first, the one in front is the same and the one behind it is opposite, which in this case it holds true. So fox is the same as turkey and the opposite of insect. Now if I'm looking at this food chain, lily pad gets eaten by the insect, gets eaten by the frog, gets eaten by the bird. So if I'm looking, we'll just say 2005 to 2006 just to keep things simple. The lily pad from 2005 to 2006, it decreased. The insect from 2005 2005 to 2006 increased. My frog increased. And then my bird increased. So I'm just going to draw my arrows up above it. Oops. This one should be increase. So which one happened first? So if I'm looking at this, if my lily pad decreased, that would not cause an increase in insects because they wouldn't have as much food to eat. So that's not possible. Now if my insects increased, would that cause my lily pad to decrease? Absolutely, because there would be more predators for it. Now if my insects increase, would that cause my frogs to increase? Absolutely, because they would have more food. So I'm going to put a dot next to it because that one could have worked out, because then it would cause my bird to increase. If my frog increased, would that cause its prey to increase? No, so that can't be it. If my bird increased, would that cause its prey to increase? No. So the answer should have been insect, which it holds true to what that guy from the video said. This, whatever happens, before it is the opposite and after it is the same. So both of these are the same and that is opposite. Let's try yet one more. If I've got algae, fish, bird, bobcat, so I'm going to draw my food chain in, and you can draw these on your whiteboard if you want. Just for ease, let's go ahead and say 1980 to 1981, and we're going to go ahead and see what population changed between those. So from here to here, it looks like it went up. From here to here, it went down. Here to here, it decreased. Increased. It increased from here. And from here to here, it decreased. So if I'm trying to figure out what happened first, let's look at algae. If the algae increased, would that cause the fish to decrease? No way, because they would have more food. Fish decreased, would that cause an increase in algae? Yes, because they would have less predators. Would that cause an increase in the birds? If the fish decreased? No, because they'd have less food to eat. Birds increase, would that cause a decrease in fish? Yes. Would that cause a decrease in bobcats? No, because they'd have more food to eat. The bobcats went first. Would that cause a decrease in birds? Yes, because they'd have more predators, which would then cause all of those other changes. Now let's flip over your page protector. If I'm looking at this one, some people kind of flip out when they see these different line graphs, but just like with predator prey and the oh deer, the population change doesn't happen in an instant at the same time like it just did with those charts. It happens over time. So say that, let's look at, say this one where we've got our rabbit and we've got our fox. So if I'm trying to figure out what would happen to the rabbit population, why did the rabbit population increase from, let's say, 40 to 55? So I'm just going to focus on this area. So what caused this rabbit population from right here? The key is to look what happened right before it. So if I'm looking to see what happened right before it, the fox population was decreasing. You can kind of see it right here. It's starting to decrease. So if there's a decrease in predators, its prey is going to end up increasing. Let's try another one. So if I'm looking at this population where we've got, this is a rabbit, the hare, and then the lynx. So what would I expect to happen? Why would, if we're looking from 0 to 5, right here, why would the hare be increasing? Look and see what's happening also at that time. The bobcat is decreasing, so if there's less predators, then the prey are going to end up increasing. Alright, let's try this very last one. If I've got my bobcat population and my hare population, which is this rabbit, if I'm looking at, oh, say between 8 and 15, I'm just going to focus on this section, what would cause my bobcat population to end up decreasing? Well, if I look right before it, right here, I've got my hare population, which is the prey. The prey is decreasing, which would then cause a decrease in its predator.